Most people store scraped data in whatever was easiest to reach for on day one, usually a single Postgres table, and then spend the next year fighting it. The table grows past what it was meant to hold, the analytics queries crawl, and every schema change on the source side turns into a migration headache. Scraped data does not have one right home. It has three, and the skill is knowing which piece of your data belongs in which. Today, I want to walk through Postgres, Parquet on object storage and a warehouse, and where each one actually earns its place. I run production scrapers for a living, and pulling the data is only half the job. The other half is storing it so it stays queryable, deduped, and cheap as the volume climbs into the tens of millions of rows. I have made the expensive mistakes here, dumped everything into one database until it groaned, and paid warehouse bills for queries a flat file would have answered for free. So I am going to keep this concrete, about what goes where and why. 3 homes, not one. Think of it as 3 tiers, each solving a different problem. Object storage holding Parquet files is your cheap, bottomless bucket for raw, high-volume capture, the stuff you want to keep but rarely query directly. Postgres is your operational layer, the deduped, indexed current state you serve queries against day to day. A warehouse like BigQuery or Snowflake is where analytics at scale lives, the place you run heavy aggregate questions over your whole history. Almost all the pain people feel comes from asking one of these to do another one's job. Land the raw capture first. The first move is to separate raw capture from clean state. When your scraper pulls a page, do not parse it and throw the original away. Write the raw response somewhere cheap and untouched first, then parse from that copy. I land raw HTML or raw JSON responses straight into object storage, one file per fetch or batched before a single field gets extracted. The parse step reads from there, never from the live site. This one split is the difference between a fragile pipeline and a forgiving one. Remission before clean. Here is why that ordering matters so much. Sites change their layout without warning and your parser will break. If you kept only the clean parsed rows, a parser bug means you have to rescrape to recover, hammering the site again and hoping the old data is still there. If you kept the raw capture, you just fix the parser and reparse the files you already have offline for free. Raw storage is cheap insurance against your own future mistakes. What Parquet actually is. So why Parquet for that raw and semi-clean layer, and not just a pile of text files? Parquet is a columnar file format. Instead of storing row by row, it stores all the values of each column together, which compresses far better because similar data sits next to itself. It is also typed, so a number stays a number, and it carries its own schema. For large volumes, you scan a few columns at a time. It is dramatically smaller on disk and faster to read than CSV or JSON, and every warehouse and analytics tool reads it natively. Why not just CSV or JSON for the raw layer? For small jobs, CSV and JSON are perfectly fine, but at volume they hurt. JSON repeats every field name on every record, so a million rows carry the same key names a million times, and it is slow to parse. CSV throws away type informations, so every read has to guess what is a number and what is a date. Neither compresses like a columnar format. I keep JSON only for the truly raw untouched capture, because it preserves exactly what the site sent, then convert to Parquet once the shape is known. Postgres is your operational truth. Postgres is where your clean current queryable state lives. Once you have parsed a record, this is the row you actually use. Look up, join against, and serve to whatever consumes the data. It gives you real indexes, real constraints, transactions, and asynchronous everyone on the team already knows. For operational work, looking up one entity, filtering a few thousand rows, enforcing that a record is unique. Nothing beats a boring relational database. Using Postgres is not the mistake. The mistake is trying to keep every row byte you ever scraped inside it. Dedupe keys are the whole game. The most important thing you do in that operational layer is dedupe, and it starts with choosing a key. Every record you scrape needs a stable natural ID, something the source itself defines, a product code, a listing ID, a canonical URL. That key tells you whether a row you just parsed is new or something you already have. Put a unique constraint on it in Postgres. Without a stable key, you cannot dedupe, and your table quietly fills with the same entities over and over until nothing about it can be trusted. Idempotent writes with upsert. Once you have that key, you make your writes idempotent, meaning running the same insert twice changes nothing the second time. Postgres gives you this directly with an upsert, an insert that says, on conflict with the key, update the existing row instead of creating a duplicate. This is what lets your pipeline retry safely. A run dies halfway, you start it again, and the records that already landed overwrite themselves cleanly instead of doubling. Idempotent writes plus a unique key make a scraper safe to rerun, which you will do constantly. Schema drift and the JSON-B escape hatch. Sites change their fields, and a rigid table will fight you over it. A source adds a column, renames one, or returns a value in a new shape, and suddenly your clean schema does not fit. This is schema drift, and you plan for it instead of getting surprised. I keep a set of stable core columns I am confident about, the ID and the key fields I always need, and the JSON-B column that holds the rest of the record as is. The structured columns stay clean and indexed, and the messy changing parts live in JSON-B, where a new field never breaks anything. When Postgres starts to hurt. Postgres is excellent right up until it is not, and you want to know the signs. When a single table climbs past tens of millions of rows, and your queries turn into big aggregates scanning most of it, a row store starts to struggle. Counting across 100 million rows, grouping by month over all of history, joining several large tables for a report. These are analytics questions, and a database tuned for operational lookups does them slowly and at the cost of the work it should be doing. That slowdown is the signal you have outgrown one tier and need the next. The warehouse is for analytics at scale. That next tier is a warehouse, something like BigQuery or Snowflake. These are built for exactly the queries that make Postgres sweat, scanning and aggregating enormous columnar datasets. They separate storage from compute, so your data sits cheap and you only pay for the horsepower when a query runs. They read Parquet natively, so loading your raw layer in is straightforward. When you need a heavy analytical question answered across your entire scraped history, this is the tool that answers in seconds what Postgres would grind on for minutes. A warehouse is not an operational database, but do not make the opposite mistake and try to serve live traffic out of a warehouse. Warehouses are built for big scans, not fast single-row lookups, and they usually charge by how much data each query scans. Point an app at one for constant small reads and you get slow responses and a surprising bill. Keep the operational serving in Postgres and the heavy analytics in the warehouse, and let each do what it is genuinely good at. The layered pattern I actually run, so here is how the three fit together in practice. The scraper lands raw responses as files in object storage, cheap and permanent. A parse step reads those, extracts clean records, and upserts them into Postgres keyed on a stable ID, the deduped operational truth. Then, on a schedule, the clean data loads into the warehouse as Parquet for analytics over the full history, raw for recovery, Postgres for serving, warehouse for analysis. Each layer feeds the next, and none is ever asked to do a job it is bad at. Choose by volume and query pattern. If you remember one rule from this, make it this. Choose your store by volume and query pattern, not by habit. Small data you look up and update row by row, that is Postgres. Huge volumes of row capture you rarely query directly, that is flat Parquet on object storage. Heavy aggregate analytics over everything, that is a warehouse. Most real pipelines want all three at different stages, and the ones that stay healthy put each slice of data where its size and access pattern actually fit. The cost reality. Money makes the choice for you more often than performance does. Object storage is astonishingly cheap, cents per gigabyte a month, so keeping years of raw Parquet costs almost nothing. Postgres sits in the middle. You pay for a running server and its disk, fine for millions of rows and painful for billions. A warehouse charges mostly by how much data each query scans, cheap if you are disciplined and brutal if you scan the whole dataset carelessly. Knowing those three cost shapes tells you what belongs where before you write a line. File size and partitioning for Parquet. One practical trap with the Parquet layer. Do not write a separate tiny file for every single page you scrape, because thousands of tiny files are slow to list and slow to read, and people hit this constantly. Batch your writes into reasonably sized files, and partition them by something you filter on, usually a date. So a query for last week only touches last week's folder. Good partitioning and sane file sizes turn object storage into something a warehouse can query efficiently. Bad ones make even the cheap layer quietly slow. The honest limits? Let me be straight about the boundaries, because storage does not change them. Where you put the data has nothing to do with whether you were allowed to collect it. Public data, a robot's file respected, an official AP or bulk feed preferred. Personal and payroll data left alone. A clean layered warehouse full of data you should not have collected is still data you should not have collected. Good architecture makes your collection durable and cheap to keep. It does not grant permission, and nothing about a fast query changes what you agreed to when you pulled the page. I run this exact layering in production, raw in object storage, deduped state in Postgres, analytics in a warehouse, so this is the setup I actually rely on, not just a picture on a slide. If you want the full versions, the written guides with real upsert patterns, Parquet's partition layouts, and warehouse load steps, plus the pics I actually use, they are at dataresearchtools.com, tested and with no undetectable promises. Storage is the unglamorous half of scraping, and it is the half that decides whether your data is still usable a year later. So to recap, do not give your scraped data one home, give it 3. Land raw capture as Parquet in object storage first, cheap and permanent. So a broken parser is a reparse and not a rescrape. Keep your clean, deduped current state in Postgres, keyed on a stable ID with idempotent upserts, and use a JSONB column to survive schema drift. Push the heavy analytics into a warehouse like BigQuery or Snowflake, and never ask it to serve live lookups. Choose every layer by volume and query pattern, and each slice of data lands where it belongs. Subscribe for a new scraping infrastructure breakdown, and I'll see you in the next one.